Welcome back. In exercise 1.1, we looked at the prime factors of numbers. Now, in exercise 1.2, we're going to prove that some numbers are endless and patternless, the irrational numbers. Real-life example. Think of a master key in a hotel. If you find a key that doesn't fit any lock and can't be duplicated by any standard machine, it's outside the system. Irrational numbers are like that. They don't fit into our neat fraction system. Engineers use these specific values to calculate the precise curve of a suspension bridge or the lens of a high-end camera. Without them, our technology would be slightly off.
Exercise 1.2. Question 1. Prove that square root 5 is irrational. We have to prove square root 5 is irrational. Let us assume the opposite. i.e., square root 5 is rational. Hence, square root 5 can be written in the form a, b, where a and b does not equal 0, are co-prime, no common factor other than 1. Hence, square root 5 equals a, b. Square root 5b equals a. Squaring both sides. Square root 5b squared equals a squared. 5b squared equals a squared. A squared, 5 equals b squared. Hence, 5 divides a squared. By theorem, if p is a prime number, and p divides a squared, then p divides a, where a is a positive number. So, 5 shall divide a also. 1. Hence, we can say, a, 5 equals c, where c is some integer. So, a equals 5c. Now we know that 5b squared equals a squared. Putting a equals 5c. 5b squared equals 5c squared. 5b squared equals 25c squared. b squared equals 1/5 times 25c squared. b squared equals 5c squared. b squared, 5 equals c squared. Hence, 5 divides b squared. By theorem, if p is a prime number, and p divides a squared, then p divides a. So, 5 divides b also. 2. By 1 and 2. 5 divides both a and b. Hence 5 is a factor of a and b. So, a and b have a factor 5. Therefore, a and b are not co-prime. Hence, our assumption is wrong. Therefore, by contradiction, square root 5 is irrational. Hence proved. Question 2. Prove that 3 plus 2 square root 5 is irrational. We have to prove 3 plus 2 square root 5 is irrational. Let us assume the opposite. i.e., 3 plus 2 square root 5 is rational. Hence, 3 plus 2 square root 5 can be written in the form a, b, where a and b does not equal 0, are co-prime, no common factor other than 1. Hence, 3 plus 2 square root 5 equals a, b. 2 square root 5 equals a, b minus 3. 2 square root 5 equals a minus 3b, b. Square root 5 equals 1/2 times a minus 3b, b. Square root 5 equals a minus 3b, 2b. Here, a minus 3b, 2b, is a rational number. But square root 5 is irrational. Since rational does not equal irrational, this is a contradiction. Therefore, our assumption is incorrect. Therefore, 3 plus 2 square root 5 is irrational. Hence proved. Question 3 first sum. I prove that 1 square root 2 is irrational. Let us assume the opposite. i.e., 1 square root 2 is rational. If it is rational, it can be written in the form a, b, where a and b does not equal 0, are co-prime integers. So, 1 square root 2 equals a, b. Taking reciprocal on both sides. Square root 2 over 1 equals b, a. Square root 2 equals b, a. Here, b, a is a rational number. Because a and b are integers. But square root 2 is irrational. Therefore, rational equals irrational, which is not possible. This is a contradiction. Therefore, our assumption is wrong. Hence, 1 square root 2 is irrational. Question 3e. Prove that 7 root 5 is irrational. First, we already know one important fact: square root 5 is irrational. That means it cannot be written in the form p by q, where p and q are integers and q is not equal to 0. Now assume the opposite. Assume 7 square root 5 is rational. If 7 square root 5 is rational, then dividing both sides by 7, which is a non-zero rational number, we get square root 5 equals 7 square root 5, 7. If 7 square root 5 were rational, then square root 5 would also become rational. But we already know square root 5 is irrational. This is a contradiction. So our assumption is wrong. Therefore, 7 square root 5 is irrational. Done. Simple logic, powerful proof. Question 3. 6 plus 2 square root 3 is irrational. We have to prove 6 plus 2 square root 3 is irrational. Let us assume the opposite. Assume that 6 plus 2 square root 3 is rational. Then it can be written as a, b, where a and b are co-prime integers, and b is not 0. So, 6 plus 2 square root 3 equals a, b. Now move 6 to the right side. 2 square root 3 equals a, b minus 6. Taking LCM, 2 square root 3 equals a minus 6b, b. Now divide both sides by 2. Square root 3 equals a minus 6b, 2b. The right side is rational. But square root 3 is irrational. So we get rational equals irrational. This is a contradiction. Therefore, our assumption is wrong. Hence, 6 plus 2 square root 3 is irrational. Hence proved. To get more videos, like, share and subscribe to the channel. Thank you for watching.